Compare the domain and range as well as any intercepts. If they exist, compare the domain and range as well as any intercepts if they exist as the functions graph below. Write domain and range as inequalities, intervals, and in set builder notation. All right, so let's go ahead and start with domain and range of f of x and g of x. With cubic functions, they both, as we can see with the green and with the purple, both go left to right for infinity on the x-axis. Also, both go bottom to top for infinity, and there's no breaks. And because of the equations themselves, then you can put in any x value. There's no restrictions like having a negative under the square root or anything like that. Same with the cubic. So they are both just all real numbers. So let's go ahead and write those first as an inequality. So it would be negative infinity is less than x is less than infinity. And then for the range, the same thing except for with y. So, and then with intervals, you just use parentheses because infinity is not a set value. And same thing for the range. And then with the set builder notation, you just need to have the set of x's such that x is in the real number set. And then it'll be the same thing for y. Okay, so now looking at the x and y intercepts of f of x. So on our graph, let's just point those out, the ones that we can see. So we see here we have negative 5, 0, and 0, negative 5. And at no other place does it touch in either of the axes. So we know f of x has the x-intercept at negative 5, 0. And then the y-intercept of g of x is 0, negative 5. So that does show that they are inverses there. Let's go ahead and find the y-intercept of f of x. Just because it doesn't show it on the graph doesn't mean it doesn't exist. So remember with the y-intercept, we know that x is going to equal 0. So we just need to plug in 0 for our function. So f of 0 equals x plus 5 cubed. So in order to solve that, so we just plug in 0 for x. So 0 plus 5 is just 5 cubed is 125. So that gives us the y value there so that we know this is the x-intercept. The y-intercept is going to be 0, 125. Now looking at the other one, then again, this was the, y in this case. And then let's find the x-intercept. So x-intercept means that y will be 0. So in our equation, we need to fill in, basically that means g of x is 0. So we just put that in our equation. 0 equals the cubed root of x minus 5. So solving there, add 5 on each side so that we can get x alone. So we get 0 plus 5 is just 5, and then cubed root of x. And negative 5 plus 5 is just 0. So then to undo the cubed root, we just raise it to the third power on each side. So those cancel, and we have x equals 5 to the third, which is 125. So now we see that we have the x-intercept as 125, 0. So notice that the y and the x and vice versa on these two equations are the opposite. They're all inverses. So we can conclude definitely that these are inverses. Let's read our answer. The cubic function f of x and the cube root function g of x are inverses of one another. The graphs of the functions are reflections of the line y equals x. The domain and range of both functions contains all real numbers written negative infinity is less than x is less than infinity, and negative infinity is less than y less than infinity, respectively, as an interval. Negative infinity to infinity, and using set builder notation, the set of x's such that x is in all real numbers, and the set of y's such that y is in the real numbers. The x-intercept of f of x is negative 5, 0, and the y-intercept of g of x is 0, negative 5. The y-intercept of f of x is 0, 125, and the x-intercept of g of x is 125, 0.